Today we're going to look at, this is the data from, I think this is from the first year that I did AP Stat. There was, I guess, like 7 people that took it that year. And I also got data from, I think the BC class was also fairly big that year. And so I had, a good sized data set.
We should do some. Never mind. That would be like 6 people. I was gonna say we should do one for this year's, but it would be 4 plus 2. So.
We could do AB also. That would be 10
They have 10 people in AB Calc.
No,
total.
Oh. I was like, wow, that's a lot.
Yeah,
Oh, so there's 4 people in that class too. You have a lot of tiny classes.
I do. And then I end the day with a class of 20.
Oh wow. That's the algebra, geometry.
Regular geometry, yeah.
Oh, regular. Is that the one my brothers are in?
Yes.
Are they in the same class?
Yeah. It's awful. They
All
are
right.
like arguing over homework at night.
Yeah, that I'm sure that's a lot of fun. All right, so we've got this data, and we're going to make different kinds of plots. And we're going to talk about why each one of them is an appropriate plot for this. So we don't do dot plots a ton. We just don't. But this is a small enough data set, and it's not spread out very much. I think a dot plot kind of works for that. So for the number of siblings, let's make a dot plot.
So for our project, could it be something like this? Because they don't really have anything to do with each other. Like the number of countries visited with the number of siblings you have.
Right. We're not doing we're doing just univariate data.
Oh, okay. So 2 things that go together. 1.
We're not doing 2 different things. So here, let's do the dot plot. So the dot plot for this. So for the number of siblings, what's the most siblings that anybody had? 5?
Yes.
So 0, 1, 2, 3, 4, 5. A dot plot's going to be kind of like a histogram in terms of, it gives you some sizes and stuff. It works really well if your data is only whole numbers.
Oh, yeah.
Right? So I'm going to let you guys count because I can't see all of it at once and still maintain, vision. How many had none?
2.
2. So we just put 2 dots. How many had 1?
3 or 4. Oh, 7.
7. How many had 2? 3?
Yes.
And 3? 4?
1.
And 5.
1.
Now, from this, we want to describe the shape, center, spread, and any unusual features. Okay? So, shape.
Unimodal.
It's unimodal. And actually, let's practice doing complete sentences. The data, and let's give context for the number of siblings. And did I actually give the context up here? Or do I just slap that up there? So if this was an actual problem, you're like, I don't know where this came from. But if it gave you more, you would talk about that. The data for the number of siblings are unimodal. Or I guess it has a unimodal distribution. I keep thinking of better ways to say things. what else do you notice about the shape?
Right skewed.
Yeah, that is right skewed.
Why do you choose those number of siblings? Just because random? Or you could do it with any of them?
Okay.
Like, oh, never mind. It says number of siblings. Sorry. I was thinking, like, why you chose that one other than others.
And there's no outliers.
Yeah, 5 might be an outlier depending on how you do it. So let's talk about the center. What could you find pretty easily? Mode is not one of the ones that we ever use, actually. We could find the median pretty easily because how many are there total?
How many what?
People surveyed. 15 people. So all we got to do is go to the 8th one from either direction.
And we know it's going to be 1 because there's 7 ones.
Oh, I see what you're saying. Yeah, because there were 2 here. If there weren't any here, then there wouldn't have been. But yeah. So the median is 1. What about the spread?
That's IQR.
So we could talk about the IQR. We could also talk about the range. Probably not going to talk about standard deviation because it's skewed data.
Yeah.
Oh, yes.
Okay?
So range could be easier. So you just take max and
Yeah. I would actually talk about on this for the spread. I would do a couple of things. The median is 1, and there are between 0 and 5 siblings for each. With nearly half being 1. Now, that's not something that it tells you to do, but that's part of the unusual features. Nearly half of the people had 1 sibling. And I might add, and only 1 sibling each for 3, 4, and 5. That's unusual that you have a tail that's that flat. And it's partly because it wasn't a big data set.
Wait, so why again aren't we doing that IQR?
You could do the IQR if you want. It's not going to tell you much on this. I think the IQR is probably going to be 1. I'm like, okay, it's not going to tell you a whole lot. But by saying that, nearly half of the data is 1 sibling, that gives you a real good, strong sense of what's going on. So, if you are looking for hard and fast, always do this, unless it's, if it's unimodal and symmetric, you're going to do the mean, you're going to do the standard deviation. If it's skewed, you're going to talk about the median, and after that, probably the IQR, but maybe not. It gets a little squidgier when you get to that part. Okay? All right. A histogram of the number of states visited. Let's see, the number of states, the number of countries visited. I put states. And that went from 0 to 10. This is going to be an interesting histogram. So this will be number of states visited. Oh, this will be the count. This will be the number of states visited.
Yeah, you see the count always goes on the y-axis.
Yeah. For a histogram, the count's always on the vertical axis.
Yes.
Yeah, let's start calling it the vertical axis because there is no y here. Now we need to decide how are we going to break this up. What is our bin width going to be?
Will be shorter, but
Maybe go what? 0, maybe 0 to 3, 3 to 6, 6 to 9,
Oh yeah.
9 to. I mean, there is no hard and fast rule for it. You know, if you find that sometimes when you do it, you're like, I should have made my bin smaller. After you do it, it happens all the time to me. I'm like, I don't like that. I need smaller bins or I need bigger bins. I think by 3 kind of makes sense on this. So from 0 to 3, is that going to include these 3s? No.
Oh no? 3's after.
It's 0 up to, but not including 3.
So
And that's a hard thing to remember. But remember, you always are going to include that left side, right? You want to start with 0 because you don't want to have it going over to the other side.
but you don't include the right side.
You don't include the right side. So let's see, that's 1, 2, I'm going to check them off. 2, 3, 4, 5, 6.
Yes, sir.
That's going to be a lot of people. I'm going to say that that's 6. And
Is that
then,
the one where the bins touch? Oh,
yes,
What's it called when they don't touch the bins?
a bar chart.
Just a bar chart.
Yeah.
What's the one that you showed us the other day that started with an M, I think?
Mosaic plot.
Mosaic. What's the difference in the distribution, right? Or-
Yeah, the mosaic, the width of it tells you about how many.
Okay.
The height tells you about the percentage. All right, so from 3 to 6, we've got 1, 2, 3, 4, 5. Don't include the 6s. 6. Were there 6 of those too?
Yes, sir.
All right, just making sure I was counting correctly. As I tell my calculus class, you have to give up something to learn some other stuff. All right, 6 to 9. There's just 2? Nine to 12, there's just 1. All right, so let's describe this one. Now we want to talk about shape, center, spread, any unusual features. I hate this eraser. I hate it so very much.
Oh.
You know what'll be easier?
Oh, yeah.
Put a white rectangle over it. All right, so distribution. So the data for the number of countries visited is, and the question came up, May and I were talking about it this morning. It's like, is that bimodal? It's still unimodal because they're right next to each other. Is unimodal and right skewed. We'll use the median again. Now, since we have the raw data, we can actually find the median here. From a picture of a histogram, we can't find the median. You may know what bin it's in, but you won't know its value. But we should be able to find this.
5?
Is it 5?
I think so. You said 8, right? Or if is it 8.5 since it's
No, it would be 8 because there's 15.
some yeah, so it'd be 5.
All right, let's just double check real quick. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, it'd be
Oh, no, it's 3.
it'd be 3.
Oh, I forgot that we didn't include 3 in the whatever it's called.
Right. So with a median of 8,
Wait, what?
How'd you get the median?
Was it
a median of, I'm sorry, 3. I was thinking about how many. I guess we can go ahead and talk about the interquartile range, again, since we have the data. So we used 8, right? So 8 was the middle, so we're going to use the bottom 7. So we'll go to the fourth one. 1, 2, 3, 4. So Q1 is 0. What about Q3? So we would come the fourth one from the top. So 10, 2, 3. Is there another 6?
I don't think so.
But there is a 5.
Yes.
And an IQR of 5. So we've done shape, we've done center, we've done spread. Are there any real unusual features? We've already talked about it being skewed. There's not much else there. All right. Number 3, it says compare shoe sizes between males and females. All right. But it didn't say what type to use. So it's, to use a poker term, dealer's choice. What do you guys think would be a good way to compare those two?
A histogram.
I'm sorry?
A histogram.
You could do a histogram. I think that would work. You could do a box plot.
Yeah.
I think that would work also.
Would you do 2? 1 for female, 1 for male?
You do one for each. When you're comparing two, I like to do box plots. You can do 2 histograms. But the nice thing about 2 box plots is you can put them on the same set of axes, and then you can compare things real easily. You don't have to look from one to the other. You will occasionally see where, I've seen this on the AP exam, where they did a vertical instead of the histogram where your axis is at the bottom, they did it vertically and stuck one on one side and one on the other side. I'll have to see if I can find a picture of one like that, where it's two histograms. Basically, they took two histograms and stuck them together.
So it's like male, female, male, like that for each like shoe size.
No. They did the whole histogram for males, the whole histogram for females.
And just put them right beside each other.
No, they actually took this one and put it underneath the other one, and then did it side by side. So I'll find you a picture. It'll make sense. I promise.
So it's kind of like the male like bars are like this way, and then like the axis, the numbers are here.
And the female bars are that way? Yes. That's exactly what it's like. All right, so we need to do a little bit. If we're going to do this, we need to split them up. So, male shoe sizes. Somebody help me out. Let's find them.
14.
That was Ian Wheatstruck.
9.5. 10.5. 11. 12. 10.5. 8 and 11.5.
2, 3, 4, 5, 6, 7, 8. All right, so there's 8 of those. Somebody had a tiny foot. 8. And then 9.5. And then 2 10.5s. An 11, a 12, and 14. Is that all of them? 1, 2, 3, 4, 5, 6, 7. Uh-oh. 5, 6, 7, 8. I missed the 11.5. This is why always at the end I count how many I have. All right, so then the median would be halfway between 10.5 and 11, so that'll be 10.75. And then we've got 4 below and 4 above. Q1 would be 10. 1, 2, and halfway between 11.5 and 12 would be 11.75. We could check to see if there are any outliers, but there might be. The IQR is only 1.75. Let's see. 1.75 times 1.5 is 2.625. If we add that to 11.75, we get 14. All right, so 14 is not an outlier because it's within that fence. If we go the other way, if we do 10 minus 2.625, we're at 7.375. We're fine. There are no outliers on this. So we could do that. And then for females,
We have 7, 11, 8.5, 8.5, 10, 7, 7. That's all.
3 of them were 7s. Interesting. So 3 7s, 7, 7, 7, 2 8.5s, and 1 11. All right, we'll work some more on this tomorrow. Hopefully tonight's homework will be less confusing for you.